Okay, welcome back. Let's take a look at the next couple of problems, and hopefully this will be helpful. Again, thank you for taking the time to study a little bit and investing in making sure that you understand things. So on number 6, it says we've got this diagram, and I want to know which ones are obtuse. Now remember, an angle is obtuse if it is bigger than 90 degrees. So we clearly have this one and this one are pretty substantial large angles. I can't call the angle TUR obtuse because it's actually technically a straight angle. It has to be somewhere between 90 and 180, but not quite. So it looks like angle 2 would be a fair one to call it. I definitely could not classify 1 or 3 as obtuse. Those are clearly acute. But now we have to go through these other ones. When we say QUT is really another way for saying angle 1, which was not true. I have RUS, which RUS right here, that's looking like angle 3, which we've already established is not true. But SUT is this one down here. It might have been angle 4 had we named it that way, but we didn't take the time. So SUT would be accurate. So I believe there's 2 obtuse angles that match those definitions. Okay. Now, number 7 is one of those nice examples of the angle addition postulate. We have these 2 angles that are marked as 5x plus 19 and 5x plus 1. But right up here, it says that angle YMC is 170. Notice it almost looks like a straight line, but it's clearly just off a little bit because it's not 180. So the segment or the angle addition postulate says the left side plus the right side equals the entire angle 170 degrees. So if I added those together, that would be 5x plus 5x is 10x, 19 and 1 make 20. But we know that all of these things together is this angle YMC, which is 70. Now, I was actually pretty nice to you. I subtracted 20 from both sides. Dividing both sides by 10, I'm down to 15 degrees. That x would be 15 degrees. But it says, now let's find YMA. Oh, so they actually do want me to find the measure of angle YMA. So they want me to turn that into a number. And also, what is the measure of angle AMC? They want me to turn this particular angle in. So I want to plug that 15 back in. So let's see, 5 times 15, because we said x is 15, right? Plus 19, we're looking at a nice angle of 94 degrees. Now, I will say that geometry teachers will sometimes purposely be misleading, and I'm not being this type. It does look like it's a little more than 90. Please understand you do on geometry, kind of when they have algebra problems, you have to trust the algebra. It's possible that this angle would turn out to be 74 degrees, even though it looks bigger. You have to trust the algebra. But 5 times 15 plus 1 is 76. Now, again, one of the reasons we a lot of times will ask you to find these extra angles is because if we checked it, the left side plus the right side should be equal to the whole thing, and that is exactly what we said the whole thing should be. Okay. Number 8. I don't know why we have 2 dots on number 8. Maybe we're trying to say it's really important. But number 8 looks like this. So, okay. I'll get you in a minute, okay? So this says we've got a linear pair. So right away, what I'd like to see you do is draw an example of what a linear pair is. So it says it's a linear pair. So that means it's 2 angles that are side by side, smashed up against each other that make a line. So I'm calling this one angle 1 and this one angle 2, just because I don't know what they are, but it tells me that angle 1 is 5x plus 13, 14x minus 4. And well, since it does add up to, since it's a line, it needs to add up to the 5 and the 14 make 19x. 13 minus 4 is 9. Somehow that has to be 180 degrees because I was told that it made a linear pair, and linear pairs are always supplementary. So let's see what we got. I'm going to take my 180 degrees that I have here. Let's take away 9 from both sides. And so we're down to 19x equals 171. And if we divide it by 19, we got 9. Now, you can't always get perfect pretty numbers, but, it's okay. Now, what's a little interesting on this one is 14 times 9 minus 4 makes this angle over here 122 degrees. 5 times 9 plus 13 makes this angle over here 58. Now, that may trouble you because I made this look like an obtuse angle and this one looked like an acute angle, but this was just a picture to help me understand how to set up the math. I really should have made this one angle 2 and this one angle 1, but it doesn't matter. It said, what is the measure of angle 2? And angle 2 is this one right here as I did it. So the measure of angle 2 is 122 degrees. And we're done. That's number 8. Okay, we'll go ahead and see if we can get one more in here. Number 9, maybe number 9 and 10. Let's see if I can execute that. This is actually a repeat question, kind of from a test that you took a little bit ago. This is clearly a simple trapezoid. And a trapezoid has this nice formula that the area is base 1 plus base 2 divided by 2 times the height. And we're going to use that twice. So the area would be 250, because that's one of the bases, plus 625, that's another base, divided by 2, multiplied by the height, 500. But then we also additionally have this other chunk over here, which is a 500 base plus 750 base. But it also has the same height as this one, 500. Now, if we go through that, let's see what that comes out to. Let's see, 250 plus 625. I'm going to divide that by 2, and then I'm going to multiply by 500. I got that that is a big number. This area is 218,750. This other one over here, let's see, 500 plus 750. I'm going to divide that by 2, but then let's multiply that by 500. That area is 312,000. This farmer has a lot of area to plant, but a square foot is not a whole lot of things. Farmers don't talk in square feet. They usually do like acres because they have such large numbers they'd have to deal with. So when I put it all together, we've got 531,250 square feet. Okay. Now, according to this, every time they buy a bag of a particular kind of seed, that's able to plant a crop that covers 2,500 square feet. So the question is, how many 2,500s would fit in that? And in this particular case, sometimes you multiply, that's how it works. In this case, every bag covers 2,500. So I'm trying to partition this into chunks of 2,500. So I'm going to divide 531,250. I'm going to divide that. Let me just type that out. 531,250, and let's divide that by 205. Oh, hey, there we go. Now, I got 212 and a half bags of seed. Now, the reality is you can't really probably buy 212 and a half bags of seed, so you're probably going to buy 213 bags of seed, but you know, you might end up keeping that extra half a bag for a later time, or maybe you had a half a bag left over from the last season, but the technical answer is 212 and a half. And so I will see you back for our final video in a little bit. All right, see ya. Have fun. Hopefully that was helpful. Have a good day. Bye-bye.